Hey guys, so this video I'm going to go over logarithms with you. I did the other video on graphing logs and exponentials, so we'll mainly just focus on the first few problems here. Before we do that, I want to remind you about some of the rules and formulas. So if you remember, for logarithms, there's that change of base formula. So for any logarithm, log base a of b. So what you can do is you can plug that into the calculator using the change of base. It just makes everything have a base of 10. Remember, we use division. You do log of b divided by log of a in the bottom. So remember, the base goes to the bottom. So it would be log b divided by log a, and it's using in your calculator, it's using a base of 10. And so that works to change the base. And then you also had exponent properties. So if you remember, I'll use x and y. So if I have x times log base b of y, the equivalent form there, remember the number in the front, can move to the exponent to give you log base b of y to the x power. That's that exponent rule. Okay. Do you remember we've got the multiplication and the division? So if you had log base b of x times y, all of that together, that is equivalent to log base b of x plus two logarithms, log base b of y. And then the last one was the division, log base b of x over y. Remember, that can be rewritten as log base b of x minus log base b of y. So these are four really important things. So 2, 3, and 4. Four important things to remember with logarithms. Remember, log of a negative number. Remember, that's not possible. Okay. Remember, log of 0 is also not possible. And log of 1, no matter the base, is always equal to 0. So those are just some reminders for you as you move through here. All right, so 1 through 4, it says round to the nearest tenth when necessary, evaluate. So log base 2 of 20, okay? So log base 2 of 20, it's really saying, well, also 2, let me move this down here. So like the rules for logarithms, if you remember with rewriting them, this is definitely a good reminder. Whenever you have log base x of y equals n, that is the same thing. I always call it going around the world. Your teacher may have said it as something different. You start at the base, x to the n power equals y. So this is the interchangeable. This is log form, and this is exponential form because the logarithm goes away. Okay? So when I come down here to number 1 and I see log base 2 of 20, if I were to set it equal to x, it would be like 2 to the x power equals 20. And you can't really do that. So you need to use change of base. So change of base is log of 20 divided by log of 2. The base goes to the bottom. Okay? Log of 20 divided by log of 2. You plug that into the calculator. You do log 20, close the parenthesis, divided by log 2, and press enter, and you should get 4.322. Nearest thousandth, that's 3 decimals. Okay? All right, number 2, if you set it equal to x and went around the world, it would be 5 to the x power equals 100, and you can't do that. 5 to no power equals 100, so you got to do change of base. So log of 100 divided by log of 5, base to the bottom. Okay, log 100 in the calculator, log 100, close the parentheses, divided by log of 5, and you get 2.861. Okay, log base 4 of negative 8. Log of a negative, when you plug that into the calculator, it's not going to give you anything because log of negatives is not possible. Okay, So now number 4, 2 to the x power equals 72. Well, the first thing you say is, does 2 to some number equal 72? Hopefully you're thinking, no, it doesn't. So when that happens, we rewrite. So we go from exponential form back to log form. Okay, so the base of the exponential is the base of the exponent of the base of the exponential here, the 2. It's going to be the base of the logarithm. Log base 2, okay? We follow the arrows. Next comes 72. Log base 2 of 72 equals the exponent. Okay, so log base 2 of 72 is equal to x. Well, we plug that into the calculator. Log of 72 over log 2, change of base. Okay, that's going to give you your answer. When you plug that into the calculator, you should get that x is equal to 6.170. Okay. All right, so numbers 5, 6, and 7 expand. So when you expand, you get bigger, right? So if you look, this says log base 2 of 3 times x times y. Okay, so going back up here, with multiplication, we bust up multiplication using addition. Okay, so if I have one logarithm, when I expand, I need more than one log. So I have 3 things being multiplied, so I'm going to end up with 3 logarithms here when I bust this up. Okay, so log base 2 goes with all of them. So I get log base 2, 3. Okay, then I bust it up again. Log base 2, next comes the x. Bust it up one more time, plus log base 2 of y. That's it for that one. Okay. All right, so number 6, that's a cube root right there. So if you guys remember way back to Advanced Algebra Part A, with the rational exponents, this is understood to be 5x to the first power. I could rewrite this as log of 5x to the 1/3 power. Do you guys remember that? There's an understood 1 here for all of that, okay? And I can rewrite this as a 1/3 power. Okay, so now I have this exponent. Remember, we go back up here. The exponent rule here says if there's an exponent, I can move it to the front, right? What ends up happening, and the way that I remember that this is expanding by moving it to the front, this is little here. When you move it to the front, font size would be bigger, so it's expanding. So I'm going to move this 1/3. It goes to the front, okay? So I end up with 1/3 in front of log of 5x, okay? Well, I'm still not done because this 5x is 2 parts, and I need to bust that up, okay? So I'm going to go a little bit further here. I'm going to continue, and I'm going to say that's 1/3, and I'm going to bust this guy up. Log of 5 plus log of x, okay? That busts up the multiplication. You can bust it up with addition, and then you could leave this here, or you also could distribute, and you can get 1/3 log of 5 plus 1/3 log of x. Okay, and number 7. So hopefully you guys see here, this is log base 3 of all of this. 5 divided by x to the 3rd. So I need to bust up division. I bust it up using subtraction. The log base 3 goes with everything. Log base 3 of the top, which is 5, minus log base 3 again of x to the 3rd power. Okay, I can't stop here because there's an exponent. When I expand, the exponent has to move to the front. The first one's fine. Log base 3 of 5 minus, I got to move that guy to the front. 3 times log base 3 of x. And there's my final answer. Okay. All right, so number 8, 9, and 10, we are condensing. Condensing means make smaller, okay? So first thing, since with expanding we moved exponents to the front, You're going to do the opposite for condensed. For condensed, you're going to move numbers to the back. So that 2 needs to move to the exponent, and that 4 needs to move to the exponent. So I get log base 3 of x cubed minus log base 3 of y to the 4th. Okay, so I'm trying to go from more than one logarithm to 1. All right, so now I notice there's this minus sign in the middle. So minus sign, we bust up division into subtraction. So when we combine it back, we go back to division. So the log base 3, I only have one log base 3 because I want one logarithm. I don't want log over log. That's not how that works. Log over log is only change of base, not condensing. Log base 3 of what comes first, x cubed, divided by y to the 4th. And there's your final answer. Okay. All right, so number 9 just kind of looks weird. So just stay with me here. Log 4 plus log x. Let's just ignore that over 2 for now. Can I combine these two here on the top? So I need this to be one logarithm. So I'm going to rewrite this as one logarithm. We multiply because there's addition in the middle, so you multiply 4 times x. So this condenses down to log of 4x all over 2. So my question is, this is being divided by 2. Would you agree with me that this is the same thing as 1/2, I could bring that 2 out to the front, times log of 4x? Do you see what I'm doing? So when I rewrote this with the fraction in the front instead of this in the denominator, I can then take this 1/2 and I can move it to the exponent of the 4x. So I get log of 4x. There's 2 parts, so this is going to both of them. Log 4x to the 1/2 power. You could stop there, or you can also know, hey, a power of 1/2 is the same thing as a square root. So it'd be like log of the square root of 4 times x. Both of these would be acceptable. So the over 2 is just crazy. You just bring it to the front as a 1/2 and move it to the exponent. All right, so 10. First thing I notice is that 4. That 4 is going to have to go to that exponent. Okay, so that's log base 5 of x to the 4th plus log base 5 of y minus log base 5 of 7. And I'm going to work left to right. So I'm going to condense this first part here. So I have addition in the middle. When I condense down, I use multiplication to multiply the 2 variables. The log 5 becomes 1, log 5, and I multiply x to the 4th times y. So log 5 of x to the 4th times y minus log base 5 of 7. So now I'm ready to condense one more time. So now I condense the subtraction. And the way that I'm going to condense the subtraction is division. So this is going to be equivalent to log base 5 of x to the 4th y divided by 7. Okay? All right, so 11 through 15, we're solving equations. So there's different cases. So hopefully you guys will kind of remember some of this. Whenever you get down and you have log equals log, you can drop the logarithms. I'm not sure if you guys remember that. When you have one log equals a number, then you go around the world to solve it. Okay? So my first one, I have 3 logarithms here. So I didn't say anything about 3. My question is, can I condense this left side? Log minus log, bases are the same. I can condense this. So I condense subtraction with division. So log base 8 of x over x to the 5th. I'm condensing the left side down. The reason I'm doing that is because once I condense the left side, I now have log equals log. And if you remember, when you have log equals log, you literally drop the logarithms, and what's left comes out and you solve it. So what's left is x over x minus 5 equals 34. Okay? So it's really like 34 over 1, and you just cross multiply. X times 1 is x. Okay, x times 1 is x. It equals 34 times x minus 5. It's a linear equation. Okay, so that's x equals, I distribute the 34x minus 170. We just solve it like we do normal linear equations. You subtract 34x from both sides. So x minus 34x, I'm running out of room, is negative 33x. That would go away. Equals negative 170. So you divide by negative 33. Okay, so negative 170 divided by negative 33, that just gives you x equals 170. That looks like a negative. X equals 170 over 33. So you really just want to make sure that you go back and check to make sure when you plug it in it doesn't give you a negative. So 170 over 33 as a decimal is about 5.2. So what I do is I go back and I check, all right, if I put a 5.2 there, it works. If I put 5.2 there, I want to make sure it's not a negative, and 5.2 is bigger than 5, so that would work. So there's your final answer. Okay. All right, so number 12, hopefully you noticed there's 2 logs on one side. So we need to condense again. What ends up happening here is I'm multiplying the 9 and the x squared minus 2. So that's going to give me log base 7. So these multiply, right? Okay. And I would end up distributing, I'm going to go ahead and do that. 9 times x squared is 9x squared, and 9 times negative 2 is negative 18. The reason this happens, okay, is because when you condense down, you multiply together. Remember? So that's your rule. If I go back up here, when I condense addition, these multiply together. So what's ending up happening here, maybe I'll write it over here. You end up with, let me just draw an arrow for this guy right here. What you end up with is log base 7 of 9 times x squared minus 2. That right there is what gives me the 9x squared minus 18. All right, it equals 1. So this is log on one side, number on the other, so we go around the world. Okay, 7 to the first power is 7. And it equals 9x squared minus 18. All right, so it's not a quadratic because the 18 and the 7, they don't have x's attached to them. So, well, I'm sorry, it is a quadratic, but we're not going to factor. We're going to solve by extracting the square root. So instead of factoring, we're going to add 18 to both sides. That'll go away. I'll bring that over here. I get 25 equals 9x squared. You divide by 9, okay, and you end up with 25 over 9 equals x squared. So then when you square root both sides, you actually end up with something you can take the square root of. You end up with x equals, and remember, it's a quadratic 2 solutions, plus or minus. The square root of 25 is 5. The square root of 9 is 3. All right, so then I go back and I check, does the positive work? Does the positive 5 over 3? Well, if you were to square that, 5/3, so if you punch that in the calculator, you do parenthesis 5 divided by 3, and you square it, and then you're going to need to subtract 2 from it since that's in the parentheses. Minus 2, you want to make sure you get a positive number, and you do. You get 0.7, and then you do the same thing with negative 5/3. So parenthesis negative 5 divided by 3, close that parenthesis and you square it, and then you subtract 2, and you get the same thing. So it works. You just have to make sure that when you plug it back in, you get a positive number because you can't take the log of a negative. Trying to separate these out. I'm using a lot of space. Okay, so 13, again, it needs to condense. It's going to end up being multiplication because there's addition in the middle. This is going to end up being log of x times x plus 3. So you end up distributing there to give you x squared plus 3x equals 1. Okay, when there's no base, remember it's an understood 10. So I have 1 log equals a number. I go around the world. I get 10 to the first power equals x squared plus 3x. Now this one is a factorable quadratic because there's that linear term there. So when you subtract 10 from both sides, you get 0 equals x squared plus 3x minus 10, and that's what gets factored. So I've got an x squared, so that's an x and an x. I'm looking for factors of negative 10. 1, 10, 2, and 5. That add to give me a positive 3. So I need to multiply to get a negative, so one of them needs to be a negative here. And I need to add to get a positive 3. So that means the negative's got to be smaller since I had to get a positive. So there you go. X minus 2, x plus 5. So those are the factors. Negative 2 times 5 is negative 10. Negative 2 plus 5 is 3. And then we solve them. So if you set this equal to 0, you end up getting x equals 2. And when you set this equal to 0, you get x equals negative 5. So then you always have to go back to check. So if I take the 2, that would go there. That would be fine. 2 plus 3 is 5. 2 works. But when I take that negative 5 back, I would get log of negative 5. And I can't do that. He doesn't work. He's extraneous. Okay. All right. 14. So I now have subtraction. So I need to condense. Subtraction goes with division. So I get log base 4, and I'm going to use division here, of x over x plus 3 equals log base 4 of 6. I have log equals log. Log equals log, we drop the logs, and then you bring down what's left. So I'm left with x over x plus 3 equals 6, and I could go ahead and put it over 1, and we cross multiply. Okay, so what that's going to give me is, and I'm going to bring that up there actually, x times 1 is x equals 6 times x plus 3. So x equals 6x plus 18 because you distribute right there. Subtract 6x from both sides. So when I subtract 6x from x, I get negative 5x equals 18. And then we divide by negative 5. So you get x equals negative 18 over 5. All right, and then you go back and you check negative 18 over 5. Well, when my only solution is negative and I've got an x by itself, that guy is out. He doesn't work. So this is no solution. So no solution for 14. All right, and lastly, 15. This is like one of the ones we did up at the top. 3 to the x power equals 25. Well, 3 squared is 9. 3 to the third is 27. So I can't solve that just by changing the base. So what I need to do is I need to rewrite this as a logarithm. So you get log base 3 of 25 equals x. So this is a change of base in the calculator. So it will be log 25 over log 3. And what that's going to give you is 2.930. Okay. All right. So last one, number 16. This is the last one I'm going to do. You buy a house for $125,000. Suppose the value increases at a rate of 5% each year. How many years will it be before the house is worth $160,000. Okay, so you're purchasing the house for $125,000. That's what you start out with, right? That's the original cost of the house. It increases 5%. That's 1 plus 0.05%. Because remember, you have y equals a times b to the x, and then there's also a times 1 plus or minus r to the x. Increase by percent is the plus r, decrease by percent is minus r. And I want to know how many years x is it going to be before the house is equal to the value is $160,000. I'm going to move this over here so I can solve it. So that's the equation that you are working to solve. All right, so it's an exponential, and I need to solve and get x by itself. All right, so do you guys all agree that the 1 plus 0.05 can be added to give me 1.05? Okay, hopefully we all agree with that. And hopefully we all agree, too, that the first step in solving this would be to divide both sides by 125,000. Okay, so I'm going to do that. That's going to go away. I'm going to rewrite this as 1.05 to the x power equals, you're going to divide 160,000 divided by 125,000. You get 1.28. All right, now you can't do that, right? That's an exponent, so you got to go around the world. So you get log base 1.05 of 1.28 equals x. It's a change of base, okay? So you're going to do, in the calculator, log of 1.28 over log of 1.05 base to the bottom. All right, so log of 1.28, close the parentheses, divided by log of 1.05. And you get 5.1 years. Okay? All right, so this is where I'm going to stop with logarithms because I've already worked a separate video going over graphing exponentials and logarithms, so I'm not going to work through all of these. The answer keys are posted. So just go back and watch those videos if you need to. And here is, I'm not real sure what I just did, but some of this you can go back if you need to look over some of these other answers, and the worked out key is also posted on the website. So good luck.